Alright, hello lads, so this is going to be a quick run through of all the trig you're going to need for the leaving cert. Okay, so we'll start with the simplest one, the right angle triangle. So here we have a right angle triangle. A right angle triangle is a right angle triangle because one side, one corner has a 90-degree angle. Okay, now what's important to note is the side opposite it will always be the longest side of a right angle triangle. It'll always be the side opposite the 90 degrees. Okay, so let's just take an angle in here. So from the point of view of this angle, the longest side has a name. It's called the hypotenuse, and we'll call it hype for short. Okay, it also has an opposite side to it. Its opposite side, its pair, and we'll call that the opposite side. And then the third side, if you've identified the opposite and you've identified the hypotenuse, the third side will always be called the adjacent side. So that's some just simple terminology. Now, the first thing we're going to learn is about the theorem of Pythagoras. And the theorem of Pythagoras is very, very simple. It says that theorem of Pythagoras says that when I get the length, these two lines denote length, of the hypotenuse, and I square it, it's equal to the sum, that means add the square of the length of the other two sides. Okay, so I'll show you this with a real life example. Let's call that 5, 3, and that's 4, and there's your right angle. So I've identified the longest side, the hypotenuse. So what Pythagoras says is that 5 squared should be equal to 3 squared plus 4 squared. Let's check, is that right? That's 25. Is that equal to 9 plus 16? Well, it is. So that's Pythagoras. Okay, now why do we use Pythagoras? We use Pythagoras because it's the quickest way to find the missing side if you know two of them. So I'm going to show you two scenarios here. Okay, these are both right angle triangles. So in this case, let's say this is 3 and this is 9 and this is x. And let's say in this case, this is 13, this is 5, this is 13, and this is x. Now let's look at the difference between these two triangles. If you notice in this one, the longest side is missing. This is missing. And in this one, the longest side is not missing. So there's only two possibilities when you're solving a sum using Pythagoras. Either the longest side is missing or it's not. So if the longest side is missing, to find the longest side, you just get the square root of the square of the sum of the other two sides. See how that's done? So you get the square of the square root of the square of the sum, excuse me, of the other two sides. And there's your answer, 3 root 10. Or 9.5. Now, this time, if the longest side is not missing, you get the square root of the square of the two sides. Sound similar, but you take them away. And you get 12 in that case. Okay, so that's the only difference between the two types of Pythagoras. In the case where the longest side is missing, you just add the squared numbers and get the square root of the answer. When the longest side is not missing, you subtract the square of the two numbers and get the square root of the answer. Now, so that's Pythagoras. Now let's have a look at sine, cos, and tan. So, again, I am going to use a simple one. Let's say this is 5, this is 4, this is 3, and there's your right angle. And let's have a look at our angle. There's A. And let's have another angle up here. Let's call that B. So, if I want to find the sine of A, or the cosine of A, or the tan of A. First of all, what are sine, cosine, and tan? Well, they're just ratios. In other words, in fancy words, they're just fractions where you take one side and divide it by another side. Okay? And it's the same, the numbers aren't the same in every triangle, but the method is, and the result will be gotten the same way. So the sine of the angle is always equal to opposite over hypotenuse. The cosine will be adjacent over hypotenuse, and the tan will always be opposite over adjacent. So let's have a look at what that is in fraction form. Opposite over adjacent. Opposite A is 4. The hypotenuse, the longest side, is 5. So there it is. I'd always give it in fraction form unless you're told otherwise. Adjacent over hypotenuse. Adjacent is 3. Hypotenuse is 5. And tan is opposite, which is 4, over adjacent, which is 3. So there's your sine, your cos, and your tan of the angle A. Now that's not the angle. If you want to find the angle, you just take one of them. It doesn't make a difference, sine, cos, or tan, and get what's called its inverse. So the sine inverse of 4 over 5 would be A. So I'll use the calculator to show you that. Shift sine inverse 4 over 5, and you get 53. But the beauty of that is it works for all of them. So if I get tan inverse of 4 over 3, I'd also get 53. Tan inverse of 4 over 3, I also get 53. So it works no matter what. Now, if I have a look at B, well, the sine of B is, well, what's opposite B? 3 over what's the hypotenuse? 5. So you notice it changes. The 5 is still there because it's still the hypotenuse no matter what you look like in the triangle, right angle triangle, but the opposite side changes depending on where you're looking from. The cos of B will be adjacent 4 over 5. And the tan of B would be, well, opposite over adjacent 3 over 4. And the same thing again, if I want to find the angle at B, I just get the inverse of one of these. Let's get the cos inverse 4 over 5, should be B. Now let's predict what it's going to be. If that's 53 and that's 90, well, 53 plus 90 is 143, take it away from 180, and we should get roughly 37. Let's see, do we? Let's get the cos inverse of 4 over 5. Roughly 37, 36.8, 37. Okay, so there you go. That's how you get Pythagoras, and that's your basic sine, cos, and tan. Now, how is the sine, cos, and tan used? Well, the first way it's used is, let's say you want to find something that's missing. So there's my right angle, okay? And let's say that's 30 degrees, and that's 10, and that's x. And I want to find x. Well, I can't use Pythagoras because I don't have two sides and one missing. I can't do that squared minus that squared equals that squared or anything like that. So let's see what I do have. I have opposite. Sorry, I don't have opposite, but I do have hypotenuse. So that's sine. So the sine of 38 must be that number divided by 10. So you can see this is a simple triangular formula where the top of the fraction is missing. Now you can guess the answer, or you can just multiply both sides by 10. So 10 multiplied by the sine of 38 would be equal to x. So 10 multiplied by the sine of 38 is roughly 6.15. And there you have it. That's how you can use it. Now I'll use another one. So let me draw a triangle this time. This time we look for the angle. So there's my right angle. And let's say I want the angle A. and I know that this is 4 and that's 8. So let's see what I have. I have opposite. I don't have the hypotenuse, the longest side. So I have opposite and I have adjacent. Opposite and adjacent is tan. So the tan of that angle must be 4 over 8. So how do I work out from the previous bit? It's the angle is going to be the tan inverse of 4 over 8. So tan inverse 4 over 8, and it's we're roughly 26 and a half. Let's call it 26.6. So that's how you can use sine, cos, and tan to find a missing side if you can't use Pythagoras. Okay?